Okay, we're going to start with number 1 on the Unit 3 study guide. The problem is to write in logarithmic form 3 to the third power equals 27. All you're doing is converting that to log form because it's in exponential form, so you need your b, your p, and your n. In this case, b is 3, p is 27, and n is 3. So log base b of p equals n, and that is the logarithmic form. So that would be the answer to number 1. Okay, let's go to number 2. This one is in log form. You need to convert to exponential form. So log base 3 of 32 is equal to 5. So you also do b, p, and n. And b in this case is 3, p is 5, and n is 32. So now I want to write that, and the b to the p equals n. So I'd write 3 to the 5th power equals 32. And now we've written in exponential form. Number 3. This one says to evaluate, which is on page, I believe page 2 of your foldable. You're evaluating log base 4 of 64 is equal to x. The first step is set it equal to x. You're given log base 4 of 64. You're told to evaluate. So you would set it equal to x and then convert. So you'd put 4 to the x power equals 64. And several ways to do this. You want to find what power of 4 is 64. So we can look in our calculator, we can use what we already know about powers, and we know that 4 to the third power is 64. So we replace the 64 with 4 to the third power. Now, since our bases are equal, that means the exponents have to be equal, which means x has to equal 3. That's number 3. Excuse me. Number 4, we're also going to evaluate. So log base 3 of 1 over 27 is equal to x. So the first step is convert, or the second step, we set it equal to x, which is the first step. So we would get 3 to the x equals 1 over 27. Okay, so different ways to think about this. You do need to remember that if I have a fraction here, and this is not a fraction, my exponent must be a negative exponent. So I know that 3 to some power equals 27, but it's going to be the negative that power. So 3 to what power equals 27? Well, 3 to the third power. So you just make it negative. And again, since the bases are equal, the exponents must be equal. So number 4, the answer is negative 3. Number 5. 5 log base 6 of w plus log base 6 of x. And we're told to condense. So the properties we would use to condense this would be the product property and the power property. I'm going to start with the power property. You just take that 5 and make it the exponent of the w. So you've got log base 6 of w to the 5th plus log base 6 of x. And now I have the product property, which means I'm multiplying my two arguments, and I have log base 6 of w to the 5th x. And if you wrote x w to the 5th, that's fine also. Okay, that's number 5. Number 6, also, this is expand instead of condense. So you have log base 7 of x to the 5th y over z. The properties, you're going to use all 3 properties in this. So I'm going to do it step by step. You can put it all in one step, but I'm going to break it down. First, I'm going to use the quotient property. So I have log base 7 of x to the 5th y minus log base 7 of z. So that's using the quotient property, first step. Second step, I need to break this up using the product property. So I have log base 7 of x to the 5th plus log base 7 of y, and I still have this second term minus log base 7 of z. And last but not least, you have to use the product property to get rid of any, or power property to get rid of any exponents. So I take that 5 and put it in front. So I have 5 log base 7x plus log base 7y minus log base 7 of z. That there is your answer. Okay, we're ready for number 7. Two natural log of x minus natural log of 6x, and you're supposed to condense. To condense this, you need to use the power property and the quotient property. So remember, this becomes the power, so I have natural log of x squared minus natural log of 6x. Quotient property, so I do this divided by this, so I have natural log of x squared over 6x. And you have to condense, or simplify this fraction if you can. Since I have an x squared on top and an x on the bottom, that would simplify to x over 6. So my final answer will be natural log of x over 6. Number 8. 4 times the natural log of 3 plus a natural log of 5x. So I have two properties again. I have the power property and I have the product property. So I'll start by doing my power. So natural log of 3 to the 4th power plus natural log of 5x. And 3 to the 4th power is 81. So natural log of 81 plus natural log of 5x. My keys. Whoops, not that one. And this is going to be the product property. So I do 81 times 5x, and I have natural log of 405x. And that's your final answer. Okay, number 9. Expand log. And since there's no base, it's base 10. You don't have to worry about writing it. So I use the quotient property first. So log 2x squared minus log of y. This doesn't need to be broken down any further, but this one, I have two things because I have a product and I have a power. So that's going to be broken down to log 2 plus log x squared minus log y. You still have to put your log y in. So now this is done, log 2. I take the 2 and put it in front, plus 2 log x minus log y. And that's your answer. Number 10, log base 9 of x equals 5. Convert, this is a solving, so I need to convert. I have it in the form b to the p, or log base b of n equals p. I need to get it into exponential form. So b is 9, p is 5, n is x. So I use 5 to the 9th power equals x. And now I can just evaluate that exponent. So x is going to equal 59,049. So 59,049 would be your final answer. Make sure you check to make sure that keeps this a positive argument, which it does, so you're good. And 11, excuse me, natural log of x plus 4 is equal to 9. Now, when we learned to solve natural log equations, I told you could do it in the calculator with the y1 and y2, but if it doesn't show up on the graph, if the graph doesn't show up, the intersection of the graph, you have to know how to use base e to solve it also. So first you want to isolate the natural log, condense and isolate everything. So all you have is one natural log on one side of your equation. I already have that here, so I can go to step 2 where I use base e to convert, to get rid of the natural log and have my argument all by itself. So I take base e of both sides. Okay, so now that I've done that, I'm going to go back and cancel out this side, and I just have x plus 4 equals e to the 9th power. And now I just need to solve for x, which means I want x by itself over here. So I subtract the 4. So x is going to be equal to e to the 9th power minus 4. So this is what you'll put in your calculator. And even if you don't have a graphing calculator at home, most scientific calculators have base e and natural log and log on them. So when you do that, you get 8,099.0839. And actually that's approximate, not equals, but that would be your answer. Make sure it keeps your argument positive, which it does. So this one is a valid answer. Number 12. E to the x plus 1 minus 2 equals 12. I want to get the base by itself, isolate that base e, so all I have is the base e on this side. So I'm going to add the 2 to both sides, and I have e to the x plus 1 equals 14. Now, since this is isolated, I can do the natural log, use the inverse, which is natural log, and it cancels out on this side, and I just have x plus 1. Don't forget, you still have a natural log of 14 over here. Put that 14 in parentheses because it's the argument that goes with that natural log. To solve for x, you have to subtract 1. So now I'm going to do x equals natural log of 14 minus 1. So when you put in your calculator, don't forget to close the parentheses because it's not natural log of 14 minus 1 or natural log of 13. That would be wrong. You use natural log of 14, subtract 1 from whatever that equals, and your answer should be 1.6391. You don't have to check this because it's okay if you have a negative exponent, even though this wouldn't make it negative. So that's the answer to number 12. 13, you have log base 2 of 3x plus 6 minus log base 2 of x equals 3. So I'm solving for x. So I need to go back to my foldable to page 3. The first step says to condense. So on this side I'm fine, I don't have any logs, but I have 2 logs on this side. So I have to condense that down to 1 using the quotient property. So I have log base 2, 3x plus 6 over x is equal to 3. Now, I also did a problem similar to this on page 8 of your foldable, except that one was a log equals log, and you drop the logs. This one is going to be convert because I don't have a log on this side. So it's going to be 2 to the 3rd power is equal to this. So 2 to the 3rd equals 3x plus 6 over x. And I know 2 to the 3rd power is actually equal to 8. So now I can cross multiply and I have 8x equals 3x plus 6. And I subtract 3x from both sides. So 5x is equal to 6. Divide by 5. And my answer is 6/5. Just check that real quick in your argument, and it's going to be fine because it doesn't make either of them negative. So the answer is 6/5. Okay, the last two are just the story problems. The one is the earthquake problem. And you remember the equation for magnitude of an earthquake is m equals log of the intensity, where the intensity is that much more intense than a regular earthquake. So I'm going to remember that that's base 10 and go ahead and convert this. 10 to the power of m is equal to I, because we need to find what I equals. And if I'm given that m equals whatever the Richter scale number is, in this case it was 6.9, I just plug that in for m. So I have 10 to the 6.9, I is equal to that, and that just equals 7,943,282. So that is the intensity. It's a pretty intense earthquake. The last one, exponential decay, because you bought a car. The original price of the car is $8,000. The rate is 9%, so that's 0.09, and it's 5 years. So for part A, it's 5 years. So the equation would be 8,000. Okay. 1 minus 0.09 to the 5th power, and that's going to give you A equals $49.92 and 26 cents. So that's how much it'll be worth in 5 years. For part B of this problem, we don't know, but we do know that half the value, we don't know the time. That's what you need to find. But half the value would be $4,000. So you're going to take your equation, 8,000 times 1 minus 0.09 to the power of x, and put that in your y1 in the y1 in the y equals menu. And then you're going to go to the table and look for when it falls below $4,000 in the y column. And that is year 8.